Why doesn't it start when I tell it to start? Take out a blank piece of paper under scientific notation. The reason they tell you this is because we have to use, the only place you will ever find negative exponents like in a usable form is when we talk about scientific notation. Okay? Now let's go back to regular scientific notation that we've already learned. If you have 6,100,000 and you're putting it in scientific notation, what does it end up being? Remember the rules, step number 1, make it between 1 and 10. Which would put the decimal where? Carter?
Between the 1 and the 6.
Right, so I move the decimal from here all the way there. Mrs. Stone?
There's no band on Thursday, despite what the schedule says.
Great. Now all my plans have changed.
I know, I was going to change all my plans too to party before band. You don't have to do that if you don't want
How many of my kids are in band?
to. 4, 8, Brianna, Riley.
But then that band never happens during any time I have them. Must be somebody else.
Well, it might have on Thursday. Who's on? They're on sometimes.
Got it. Thank you.
You are welcome.
Your next step, remember, was to put times 10. Right? And then the exponent was how many places the decimal moved, correct? Which in this case was 6. Today, ladies and gentlemen, and kids of all ages, we are going to deal with decimals in scientific notation with very small decimal numbers like this. And if I want to change that in scientific notation, what do I do with it? Well, the first 2 rules stay exactly the same. If I move the decimal between that and make it between 1 and 10, where does it go? Abram? Where would my decimal go? Make it a number between 1 and 10. Right now it's way less than 1. Let me just tell you. Move the decimal to make a number between 1 and 10.
Between 7 and 8.
Thank you! I move it all the way from here to here because 7.8 is between 1 and 10. I still write times 10. But what you must understand is this, and this is why we do this, okay? If I am taking this, if I'm taking 7.8, what would I multiply 7.8 by to get this number that I started with? 0.000078. It would have to be a very small decimal, correct? Or a fraction, 1 over whatever. Well, that is why, because we just talked about this, let me go back here. Negative exponents give me really long decimal numbers with point zeros or fractions. That is why when we get to this point here, however many places you move the decimal here gets put with a negative exponent, which is 1, 2, 3, 4, 5, 6, 7, 8. Please know, okay, sometimes people think that the number of zeros there is how many your exponent. It's not true. It's actually the number of zeros plus 1 because the decimal has to go 1 place past the zeros. It moved 8 places. 1, 2, 3, 4, 5, 6, 7, 8. And the reason that works, Amelia, is because if I were to redo this and take 7.8 and multiply it, what was my 10 to the negative 8th power? If I multiply that by 0.0000001234561, I get back to where I started from. 10 to the negative 8th power stands for this big long decimal. Multiply by that, and I'll get back to this. So now you have scientific notation both for big numbers and for small numbers. Let's look at a couple more examples. 0.0, let's do that. 0.85. In scientific notation, what is that? What would that be in scientific notation? Abram?
8.5.
Times 10. Let's put the times 10 in there just for 5. Yeah, you have to put times 10 because 8.85 is not the same thing as 8.5. You can't just say they're the same. Times 10 to what power? Abram?
2.
Nope. Remember, if it's a decimal number, it has a negative exponent. Amelia?
-1.
-1. I moved the decimal one place to get it there. It's a decimal, so it's -1. How about this? 0.00632. What is that in scientific notation? Jacob Litt, what is that in scientific notation?
6.32.
Yep, times 10 to the,
Third power.
nope. Times 10 to the, Amelia,
-3.
-3rd power. Thank you very much. 3 and -3 are not the same thing, people. How about this one? 0.000043. In scientific notation, Brant,
Robert, 3 times 10 to the 6 power.
Nope. What? Did you say -6? There you go, -6 power. I moved it 1, 2, 3, 4, 5, 6 places. How about one more? 0.00000000000849.
How many zeros is that?
I don't know, you count.
I 21.
Is there 21 zeros?
Mhm.
So the answer, Parker, is
8.49 times 10 to the -21st power.
oh, I have a feeling. I just got done saying, if you just do the number of zeros, Parker, that only gets the decimal to here.
-22nd power.
Thank you very much. -2. You with me on that? So if you're looking at the number of zeros, you have to add 1 more. And then you also have to be able to go from negative whatever scientific notation, 7.6 times 10 to the -5th power. You need to be able to change that back into standard form. And what would that be? Parker, using that same reverse psychology, how many zeros are going to come be in that after the decimal? Yes, because remember, this takes up 1 place. That's 1 of the 5. 2, 3, 4, 5 decimal point 4 zeros. 0.000076 is this number changed into standard. How about this one? 8.39 times 10 to the -3rd power. What decimal does that? What decimal does that stand for? Brant says.
0.008.
No, don't put another point in. Yeah,
8 through 9.
there you go. That is that right there. Everybody with it? You got negative exponents. You got scientific notation. Don't worry.